You think you know how a knife works. You think it's simple. You push a sharp piece of metal into a tomato. The metal physically touches the skin and it separates it. Wrong. You have never cut anything in your entire life. In fact, nothing has ever touched anything else. If you watch my video on why you can't touch your desk, you already know your hand is hovering via electromagnetic repulsion. But immediately people asked, if I'm not touching anything, how does a knife cut? How does sandpaper scrape? Why do my car tires wear down? It's a brilliant question, but your intuition is misleading you. By the end of this video, you will learn exactly what friction and cutting actually are. You'll discover that you aren't physically splitting matter. You are tearing apart microscopic electromagnetic force fields using brute force quantum repulsion. Your reality is about to shatter. Let's start with the blade. You pick up a knife in your kitchen. It feels heavy. It feels solid. It feels dangerous. When you press that cold steel against a vegetable, your brain immediately writes a story. Your brain tells you, this metal is harder than this plant. The thin physical edge of the hard object is wedging itself between the soft matter, physically pushing it apart. That is the high school physics explanation, and it is completely fundamentally broken. Hold your hand out right now, look at it. Your brain tells you it is a solid object. It is lying to you. Your brain evolved to help you throw rocks, pick fruit, and run from predators on the African savanna. It did not evolve to understand the quantum mechanics of the atomic realm. It gives you a convenient illusion so you can survive. To understand the knife, we must discard the illusion. We have to zoom in, way in, past the cells of the tomato, past the crystalline lattice of the steel, down to the atoms. What is an atom? Stop picturing a little solar system with a nucleus in the middle and electrons flying around it like planets. That picture is a cartoon. Atoms are almost entirely empty space. If you scaled a single atom up to the size of a massive professional football stadium, the nucleus, the only part with any real mass, would be a single grain of rice sitting right on the 50-yard line. The electrons? They are microscopic ghosts teleporting around the uppermost bleachers. Everything else? A complete, terrifying void. So when you bring the knife down onto the tomato, you are not bringing two solid objects together. You are bringing two massive empty voids together. If they are just empty space, why don't they just pass right through each other, like two ghosts walking through the same hallway? Because those electrons in the bleachers carry a negative electrical charge, and the universe has an absolute, unbreakable, ironclad rule, like charges repel. The electrons in the steel blade absolutely despise the electrons in the tomato skin. They push away from each other with a force so monumental it defies human comprehension. The electromagnetic force between them is 10 to the 42nd power times stronger than gravity. That is a 1 with 42 zeros behind it. So the knife does not touch the tomato. It cannot touch the tomato. The electron cloud of the knife hovers just above the electron cloud of the tomato, screaming at it to get out of the way. But this brings us right back to your excellent questions in the comments. If all they do is push each other away in empty space, why does the tomato split? Why doesn't the tomato just get pushed downward, completely intact, into the cutting board? If it's just a magnetic hovercraft, why is there destruction? To answer that, we have to ask a deeper question. Why is the tomato a tomato in the first place? If all electrons hate each other, why do the atoms inside the tomato stick together to form a shape? Why doesn't the tomato just explode into a mist of atoms the second it grows? Because of chemical bonds. When atoms get close enough to each other under very specific conditions, they realize something. They realize that by sharing a few of their outer electrons, they can drop into a lower energy state. The universe is incredibly lazy. Everything naturally wants to be at the lowest possible energy state. Picture a heavy boulder rolling down a steep hill and getting stuck in a deep valley at the bottom. It takes a massive amount of energy to push that boulder back up the hill. The atoms inside the tomato skin are trapped in that valley. They are bound together. They don't want to be separated because separating them requires a massive injection of energy. They are holding on to each other for dear life. So now let's look at the knife again. A knife is not a physical wedge. A knife is an infinitely concentrated electromagnetic force field. When you sharpen a knife on a whetstone, what are you actually doing? You aren't polishing it. You are violently stripping away atoms of steel until the edge is incredibly thin. You are narrowing the electron cloud down to an absolute microscopic razor's edge. You are creating a pinpoint focus of electromagnetic repulsion. Now apply force. You push down with your arm. You are taking all the gravitational weight and all the muscular energy of your arm, and you are focusing it entirely onto that microscopic, invisible line of repelling electrons at the edge of the blade. The repulsion gets monstrously strong. The electron cloud of the blade is violently crushing the electron cloud of the tomato. Think about trying to force two incredibly powerful magnets together with the same poles facing each other. You feel that squishy, invisible resistance in the air. Now imagine those magnets are 1,000,000 times stronger, and you have a fragile, brittle object caught between them. The atoms in the tomato are caught in the middle. The blade's repulsive force is commanding them to move apart, but remember, they are chemically bound to each other. They are stuck in that low-energy valley. The pressure builds. The downward force of your arm increases the electromagnetic repulsion to an astronomical level. The atoms are trapped between the crushing magnetic push of the knife and their desire to stay bonded together. Finally, the repulsive force of the hovering blade becomes greater than the chemical binding force holding the tomato's atoms together. Snap! The chemical bonds break. The atoms are violently ripped out of their low-energy valley. The tomato literally tears itself in half just to escape the terrifying, crushing pressure of the knife's hovering electron field. The knife never touched the tomato. It commanded the tomato to rip itself apart using invisible quantum-level magnetic pressure. Now let's address the second part of your brilliant questions from the comments. Many of you said, okay, fine, I can accept that cutting is just focused repulsion. But what about a saw? How does a saw cut wood? Or what about sandpaper? If you rub sandpaper on a desk, it scrapes wood away. How is that possible without physical contact? It is the exact same illusion, just applied differently. You look at a piece of smooth wood and your brain tells you it's a flat surface. It is not. If you shrink down to the atomic level, that smooth wood is a chaotic, jagged, terrifying mountain range of atoms. It is full of peaks, valleys, cliffs, and deep ravines. Sandpaper is also a mountain range, but its peaks are made of incredibly hard, stubborn materials like aluminum oxide. When you press sandpaper against the wood, you are doing the hovercraft trick again. The sandpaper is hovering over the wood. But because both surfaces are jagged, microscopic mountain ranges, their invisible force fields overlap. What happens when you drag a mountain range of force fields across another mountain range of force fields? Do they just slide smoothly like two magnets slipping past each other? No. The invisible repulsive peaks crash into each other. As you push your arm forward, the electron fields of the sandpaper's peaks violently slam into the electron fields of the wood's peaks. The repulsion is immense. It's a microscopic, catastrophic car crash of electromagnetic fields. The force of this crash is so violent that it completely shatters the chemical bonds holding the top layer of the wood's atoms together. Chunks of molecules are ripped entirely off the mountain. They break away, tumbling into the valleys. This is what we call sawdust. A saw does the exact same thing, just with larger, more organized peaks, the teeth of the saw. The teeth are plowing through the invisible fields of the wood, utilizing blunt force electromagnetic collisions to shatter the bonds of the wood molecules and throw them out of the trench. You are not scraping solid matter. You are detonating chemical bonds through magnetic collisions. But this leads us to the most uncomfortable paradox of all, the one that engineers and mechanics in the comments were furious about. Why do my car tires wear down? If friction is just hovering and repelling, why does my tire lose rubber on the highway? To understand this, we have to look at the darkest secret of empty space. When a rubber tire hovers a fraction of a nanometer above the asphalt, it isn't just a simple push-away scenario. The electromagnetic force isn't just about pushing, it's also about pulling. The molecules in your tire and the molecules in the road are massive, long, and complex. They have clouds of electrons that are constantly shifting, swashing, and jiggling. Because these clouds shift, they create momentary, tiny imbalances in their electrical charge. For a billionth of a second, one side of a molecule might be slightly positive and the other side slightly negative. When your tire gets agonizingly close to the road, these slight electrical imbalances reach across the empty void. The positive side of an asphalt molecule feels the negative side of a rubber molecule across the gap, and they grab each other. Pause. Picture this in your mind right now. Millions of invisible microscopic bridges forming in the empty vacuum between the tire and the road. This is called chemical adhesion, specifically van der Waals forces. The tire is stuck to the road by millions of invisible magnetic tractor beams, but your car is moving at 60 miles per hour. The engine is forcing the tire to spin violently. So what happens? The tire is being dragged forward, but the invisible magnetic bridges are refusing to let go. Something has to give. The rotational force of the heavy engine fights a brutal war against the electromagnetic bridges holding the rubber to the road. The engine is stronger, but the magnetic bridges are so incredibly stubborn that instead of simply letting go, they violently rip the rubber molecules completely out of the tire. The internal bonds inside the tire snap. The rubber atom is torn away from its friends and left behind on the asphalt, locked in its new magnetic prison. Your tire isn't wearing down from physical contact. Your tire is being slowly dismantled, atom by atom, by billions of invisible magnetic tractor beams tearing its flesh away as you drive. That is what friction actually is. And all of this violence, the ripping of the tomato, the shattering of the wood mountains, the tearing of the rubber, it all requires massive amounts of energy. When you rip those chemical bonds apart, the atoms snap back. They jiggle violently. They vibrate with the shock of the separation. And what is atomic jiggling? We've talked about this before. Atomic jiggling is heat. When you run sandpaper over wood, it gets hot. When you slam on your brakes, the tires smoke. When you cut through thick steel with an angle grinder, sparks fly everywhere. That heat is the death rattle of 1 trillion chemical bonds being electromagnetically shattered. It is the raw kinetic energy of atoms screaming in vibration because you just forced them out of their comfortable, low-energy valleys using nothing but repulsive magnetic fields. Your brain doesn't like this. I can feel your resistance. You want the world to be simple. You want a knife to just be a sharp physical thing, cutting a soft physical thing. You want friction to just be two things rubbing. But the universe doesn't care what you want. The math shows us this is the absolute bedrock of reality. When you finally understand this, you stop being a passive, confused observer of the world. You start seeing the underlying matrix of forces around you. You stop seeing objects and start seeing fields of energy. To help you actually apply this mind-bending reality to your daily life, I've put together a free system for you. I call it the Feynman Quantum Lens Workflow. It is a one-page digital framework and prompt pack. It teaches you how to look at literally any everyday action: cooking, driving, playing a sport, fixing a pipe, and mentally break it down into its fundamental quantum fields and energy transfers. It is the exact 3-step thought process I use to write these videos and shatter these illusions. Step 1. Discard the object illusion. Step 2. Map the repelling fields. Step 3. Track the energy transfer. If you're a teacher, a student, or just someone who wants to break their brain in the best way possible to see reality for what it is, you need this. You can download it right now. The link is the very first thing in the description below. Get it, print it out, and start seeing the invisible world. So, the next time you step into your kitchen and prepare to chop a vegetable for dinner, pause for a single second. Look at the blade in your hand. Remember that you are not holding a solid wedge of metal. You are wielding a mathematically precise hovering edge of quantum repulsion. When you press down, you aren't touching the food. You are acting as a god of electromagnetism, applying localized catastrophic force fields to dictate the molecular destruction of matter. You are a hovering entity, interacting with a universe of floating, repelling fields, and that changes everything you think you know about reality. To help you actually apply this mind-bending reality to your daily life, I've put together a free system for you. I call it the Feynman Quantum Lens Workflow. The link is the very first thing in the description below. Get it, print it out, and start seeing the invisible world. If this video successfully broke your common sense and shattered your reality, hit the subscribe button. We have a lot more illusions to dismantle. I'll see you in the next one.